안녕하세요. Thank you again. So let's talk about AWS DeepLens. This is the world's first deep learning enabled video camera intended for developers. So we, as you may have seen, Andy Jassy, the CEO of AWS, as the video was playing, is talking about how we wanted to bring or put machine learning literally in the hands of developers so that they can learn machine learning by doing it in a fun manner. And what's cool is, if you go to the expo hall, we have a giant deep lens that's actually being demoed at the booth. So I encourage everybody to go visit the expo hall. It's really cool. So, as I mentioned, we intended to build a developer device for people to learn machine learning. And if you actually noticed in the last session, when I was talking about SageMaker and how it simplifies the flow, it's often a good thing for people who are hands-on to really get a physical device that they can learn with. So it's a fun way, and what we have done is we've provided a lot of sample projects. So, for example, artistic style transfer. So you can take any scene and actually make it look like a Van Gogh painting. It's a really cool project. Another is object detection. What we have provided is, and all of this code and the models are actually open source. We encourage you to check out, and I'm going to share some links later. With the object detection model, you can detect objects, say, hey, that's a cat, that's a person, but also locate where the object is in the image. Next, we have face recognition and detection capabilities. So you can detect faces in the image and a label or recognize who that person is. Couple of other cool models. There's a cat versus dog. It identifies. If you're familiar with the popular show Silicon Valley, there's a whole where a person, they build the hot dog app. You can actually, in less than 10 minutes, build that app yourself. Here's a cool model with activity detection where you can detect if a person's brushing their teeth, playing a guitar, etc. So in essence, we have provided a lot of samples to try and fit some of the use cases, and we will keep adding more examples where you can leverage computer vision technology but at the same time, for people who are not familiar, it's a good way for you to learn machine learning. So let's look at if we take a step back, so what are the steps that are involved as you do machine learning or deep learning, right? You start with the data. There's a whole process of collecting that data. Thanks to the cloud, at AWS with services like S3, Kinesis, RDS. All these make easy for you to collect and store data at scale. Now, once you have that data, the next step is model training. While we have services like the deep learning AMI that allow you to spin up your infrastructure, things like SageMaker makes it really simple for you to develop machine learning models at scale. The third part is inference. Like SageMaker allows you to deploy and deploy endpoints where you can consume the model, but DeepLens goes a step further where you can actually deploy it onto a physical device and do inference at the edge. So let's look at what the model training phase. So this is just to recap. So we go from a large annotated data set, we split it into training set and a validation set, we train, and we pick the best model we get from the accuracy metric on the validation data set. But really, where the magic happens is on the inference side, right? You've trained the model. Now, in the computer vision case, you'll give it an image or a video, and it'll run through the model, and then you get a predicted output. In this case, it's a face detector model. As you see, give it a raw image, and it's able to detect faces. Now, without further ado, let's actually take a look at the output. So I have an object detection model running. So you can see it's detected me. It's detected a TV monitor. This is actually trained on the Pascal VOC dataset, which can identify about 20 different objects. The code is available from a training perspective. I'll share the link. It's using the SSD, or a single shot detector model. And what's great is the model is, I don't know if people can notice all the way at the top, there is no internet. Look at that. It's running completely locally. So the inference is happening on the device. You don't need to be connected to the internet to do this. And that's really cool if you think about it, right? So there are a lot of applications where we don't have network connectivity or poor connectivity. You want to bring machine learner closer to where the data is being produced. So this allows you to prototype really quickly and understand how you can use machine learning at the edge. So just to show you another example of the object detector, as I said, like there are only 20 things it can detect, like people, water bottle. There's like dogs and cats. I couldn't find a dog, so I have a little toy. I'm gonna try and see if it's able to detect the dog. As you can see, maybe I'm too close. The lighting is pretty bad here. But you can see it detects it sometimes with accuracy. So it's really good for you to start. And as I said, you can bring data. If you wanted to build a custom object detector, you can bring your data and use the training code that we have provided to actually train the model with data or custom labels that you have. So I'm going to walk you through how you go from unboxing the device to actually having the model onto DeepLens. We really wanted to give an experience where people didn't have to log in to the device, SSH into the device, and so on. We really wanted you to use this just like any other AWS service, where you could log into the console and interact with the service. So in here, what you see is the first step is we create a project. You give it some names. Then what you can do is you can use the models that we provide. So as you create the project, if you select the face detection model, you can give the model artifact and then the function or the code that runs. And we'll get that into a second. It's running the runtime environment that's in the device. So once you have done that, you created the project, the next step is to deploy it to the device, right? You've packaged your code, you've packaged your model files, and now let's push it to the device. Next, a single account can have multiple devices, so you choose the device that you want to deploy it on. And once you've done that, you choose and you're able to deploy. So you can integrate with other AWS services. So here it just tells you that if you're sending images to S3, you might incur S3 costs and so on. And once you're done that, you'll see a blue progress bar, which, and once you have green, you know that it's deployed. So let's look at what the capabilities of these devices is. So first thing, what's the performance, right? So there's an onboard GPU, CPGPU from Intel that can give you 100 gigaflops. So that's number of floating point operations per second, for people who might not be familiar with that metric. 8 GB RAM. It comes with onboard storage, but you can actually put in a SD card, so you actually get more drive space. It's got audio out, it's got micro HDMI. The camera details. So 4 megapixel camera, so it's a fisheye camera, but with capability for 180, so 1080p resolution, which supports H.264 encoding. And the runtime environment is provided by AWS Greengrass, which is pre-configured on the device. As far as you're concerned, you don't install anything on the device. The device runs Ubuntu 16.04, so it's really good, developer-friendly, and you can, as you saw when I saw the demo, right? I logged into the device. It's just like a mini computer that you can use. So it's a familiar environment as far as the developers are concerned. The last is the CLDNN. So because of the specialized hardware that's on the device, you can take models that are built with Apache MXNet or Gluon and transfer them. Basically, you run through the optimizer. The optimizer generates a binary that can execute really fast, take all the advantages of the hardware that the DeepLens provides to get really good performance. So let's look at under the covers what's happening. So this is the console. You're basically, as I mentioned, you're packaging the model and the Lambda function. That's what you're doing. And you can log into the console, package this, and then push it to the device. And once you've done that, the device is running a local Lambda function. So people who are probably not familiar with Lambda functions, these are function as a service. So you can have events and have code respond to that. And Lambda is really cool because you don't need to actually provision servers, and it's pay as you go. So only if the function triggers, you need to pay. So you don't need to keep things running all the time to service requests. Now, Greengrass brings that capability onto edge device. So you can, on any sort of hardware or little developer kits, you can install Greengrass and run these Lambda functions locally. It's sort of like having a mini cloud on your device, or sets of device. Now, in case of DeepLens, once you run the inference Lambda function that we talk about, it has two different streams, like video streams. So you can get the output stream, which is what we saw, and you can get the raw stream, which is the project stream. So what's really cool about DeepLens is it has Greengrass, right? So which means you can connect securely to the cloud. So what you have here is you can start tying into all the other services that AWS has to provide. So for example, you can have the integration into IoT gateway. So you can actually send messages as the interpretations happen or inference happens, and maybe you can connect it to actually SNS or the notification service. What's cool is I built this app, and you saw the project. There was a cat-dog app. So I really wanted to. My friend had a cat, so I built this app, and his cat would annoy him because it would be on the couch and he didn't want his cat to do that. So we built a model that would detect the cat, and then we hooked onto SNS, and he would just keep the deep lens. So when the cat would be on the couch, it would actually send an alert to him. So he's able to track how many times his cat actually used the couch. But fun aside, as I said, you can collect the data, use other services like DynamoDB to serve or store all these inference messages that you get out. There's integration with recognition. I'll show a cool project that I built earlier in the next couple of slides. So Amazon SageMaker, this is the integration piece where you build or extend the models. So you can use already existing code or build your own models and then run it through the optimizer and then push it down to the device. So it's an end-to-end flow where you can go from data to building a model and finally getting all of that into the device itself. So here's a fun project that I was talking about. Really wanted to build Oscar companion because I didn't know most of the celebrities, and seemed like my wife knew more. So I built this app where you get similar to what we saw in the previous architecture, the images. There was a model running, so there was a face detector model running, so it would detect the faces. And it would take a long time to build a face or a celebrity recognition. So I used recognition, AWS Recognition's service, celebrity recognition service, to once a face is detected to tell me who that was. So you can build these cool hybrid applications using DeepLens. And as you can see, it's a very hacky setup, but it was able to detect the celebrities. So you can build fun projects and get your hands dirty with machine learning. Also, wanted to highlight that we had a whole community effort where people were building these really cool models, right? What are sort of the applications? Some of you may be interested in knowing what people have done so far. This is a cool app. So there's a read-to-me app where the person was able to build a deep learning-enabled book reader. So you would just have a book in front and was able to actually read the characters, and using Poly, Amazon Poly, it would actually read out the characters it saw. It's a pretty cool application. Similar, people have built interactive device for learning capabilities, where this person built an app for his children, where you would show a frame and it would tell you whether it was a cat or a horse and so on. So it allowed the person to learn, or the child to learn. We had also Safe Haven, which was actually uses Alexa. So it integrates with Alexa, where DeepLens is sort of used as a security device, where it's identifying and recognizing people who are not part of the house. And it would tell you, hey, there's a stranger in the house. So it would alert the parents. It sends a notification, all of that. So really, really cool applications are being built with DeepLens. Prototype, right? So this allows people to move faster, learn faster, iterate and see how these applications in the physical world can exist. So rapid prototyping is the key with DeepLens. So this is a really cool application, so I wanted to show you a demo. So ASL is American Sign Language, and this person was able to build an app that could recognize or read that. So I'll let the video do the talking.
H I A B C U V W X Y.
As you can see, it's a really important. It's a really important application, right? Like where you're interpreting sign languages, and this person was able to really build a prototype really fast, and now you can use and extend what AWS has to provide to scale this solution. So just as a reminder, DeepLens is integrated with SageMaker, so you can build your models, train them, all of that, and deploy it directly onto the edge device. Now let's look at a more sophisticated application. I want to give more examples as possible so that my hope is to inspire you guys to think of cool ideas and then build them with SageMaker and deploy on DeepLens. So this is an audience sentiment application where these people wanted to say you're running in a classroom environment and understand if people are actually enjoying a certain lecture and capture that. So this is a pretty sophisticated architecture, as you can see, where the DeepLens is detecting the faces. So there's a face detector model that's running locally and cropping out the faces. And this is really cool, right? Like where you're reducing the bandwidth that's needed to do a whole complicated task like this. You can imagine, right? Like an image could be like 1 megabyte, but if you crop it and just detect the faces, you probably may reduce it down to like 200K and save on the bandwidth and faster inference. So you send that into S3. Now S3 is collecting all these images. And remember, because of green grass, everything here is secure. It's all over HTTPS. And it recognizes, so it triggers a Lambda function, and the Lambda function uses Amazon recognition. So Amazon recognition calls, you get the sentiment of the people, and then you store the detected emotions, and then in DynamoDB, there's CloudWatch to actually get the metrics. And before that, as you can see, we use SageMaker to actually train the model and then deploy it onto the device. So you can really build an end-to-end architecture that starts from a physical device and all the way use the power of the cloud to augment what the inferences that you have here. I quickly wanted to show the website. So we have a GitHub link, the workshop here, which has some of the labs. So people with a device can actually go through this and learn. We have an entire community page where you can browse and get inspiration for more use cases. So some of the demos we saw are all up here. So I really encourage you guys to check these links. There are really cool and amazing projects. Computer vision. For novices, please, go take a look. As I said earlier in my talk, don't be afraid of machine learning. It's really easy, given the resources and how some of the tool set that we've brought about or released. We're capable of simplifying that machine learning as an end-to-end task for you. Here are some of the resources. Some of the links are available here. Then the presentation will be uploaded, so you'll have access to all of these links. With that, in my talk, so comes Hamnita.